Hi, I'm Sarah Papi, and I will present the paper How Do Hyenas Deal with Human Speech, Speech Recognition and Translation with ConfHyena, a joint work with my colleagues Marco Gaido, Matteo Negri, and Luisa Bentivogli from Fondazione Bruno Gessler or FPK. I will start from the motivations of this work, and we started from the attention mechanism, that is a crucial mechanism in various AI fields, including speech processing. But its quadratic computational complexity limits its use with long input sequences, such as in automatic speech recognition or ASR and speech translation ST. And for this reason, current solutions commonly employed on sampling of the input speech to reduce the length of the input, or alternative attention mechanisms that, however, led to information loss. But more recently, an alternative has been proposed, and its name is Hyena. Hyena, proposed by Poli et al. In 2023, has emerged as a promising replacement for the attention mechanism with a lower computational complexity. But different from almost all previous work in this direction, it was able to reach comparable results in language modeling and image classification. For this reason, in our work, the research question was how does Hyena deal with human speech? So, what happens if we integrate Hyena in the speech architectures? For this reason, we built ConfHyena that combines the Hyena operator into the speech architectures. And we employed a standard conformer architecture using speech processing. And instead of the attention, we replace it with a Hyena operator. But Hyena is an operator that, applied to the input, is able to process it in a causal way. So it can consider the current and the past inputs when computing the current input representation, but it is not able to look at the future inputs. That is instead a very important property for the speech processing. For this reason, in our work, we introduce also a non-causal version of Hyena that is able not only to consider past and current inputs, but also future inputs. Moreover, in our paper, we introduced a variant of the ConfHyena that is hybrid ConfHyena. So instead of replacing Hyena, the attention mechanism with Hyena in all the layers of the conformer, we adopt an architecture that has Hyena replaced in the initial layers of the architecture. Then we have the CTC-based compression, that is a module that is in charge of compressing the input representation based on the conditional temporal classification loss that is commonly used in speech processing in order to reduce the input length. And then this input representation is given to the standard conformer attention. Moving to the results of this work, we start from the quality. And first of all, we can see from the results that the causal ConfHyena and the causal hybrid ConfHyena achieve lower results compared to both conformer, but also the non-causal counterparts here in bold. While we also can observe that hybrid ConfHyena is able to achieve very comparable results compared to the standard conformer. But moving to time, and in particular training and inference time, we clearly see that the hybrid ConfHyena has very reduced training and inference times, but having the same number of parameters. In particular, we observed that the training time has been reduced by 27% and the inference time has been reduced by 7%. So moving to the conclusion, we introduced in this work a non-causal version of Hyena to replace the attention mechanism. We integrate the non-causal Hyena into the conformer architecture, realizing ConfHyena and combined with the standard conformer, a variant that is named hybrid ConfHyena. And also, we proved that hybrid ConfHyena balances the output quality because it showed all this very small degradation in performance, but very competitive computational efficiency with a reduced training time of 27% and inference time of 7%. Thanks for your attention. The code and models are already available on GitHub, and you can use the QR code to directly access to the paper. Thank you.